Hello everybody, welcome back to Higher Maths. Today we're on to some really good stuff. It is perpendicular bisectors. We are going to find the equation of a line which is called a perpendicular bisector. So first of all, let me explain what that actually is. So you can see there I've drawn a normal line that goes from A to B. I am now going to draw the perpendicular bisector of that line. The perpendicular bisector of that line crosses it in the middle of the line at a 90-degree angle, like so. So basically what we're going to be asked to do is we're going to be asked to find the equation of this new line. So we'll be given an original line with 2 points and we want to find the equation of this perpendicular bisector. Okay, now you should remember that for the equation of any line we need the gradient and we need 1 point that lies on the line. So you need to have a little think about how we would get the gradient of this line and how we would get 1 point that lies on this line. Go on, have a wee think, chat amongst your virtual selves. So the point that we're going to get that's on this line is this point here. This is bang in the middle of A and B. It is known as the midpoint of AB. That's the point that we're going to use. For the gradient, you will notice that this new line is perpendicular to the old line. You know how to find a perpendicular gradient. You turn the fraction upside down, you change the symbol. So that's what we're going to do. Right, first up, how do you find the midpoint? Okay, so let's use a slightly easier example. Let's say we had a line where this was the point 2,4, this was the point 4,10, and you had to find the middle of that line. So how would you do it? Well, you could look at the x coordinate because you want the number that's in the middle of that. So you've got 2 and 4, so in the middle of that would be 3. You would look at the y coordinates, 4 and 10, and you would want something that was in the middle of that as well. 4 and 10, right in the middle of that, is 7. Basically, you are finding the average of the x coordinates and you're finding the average of the y coordinates. Just have a look. That was 3. 2 add 4 makes 6. Half of 6 gives you 3. 4 add 10 gives you 14. Half of 14 gives you 7. This is known as the midpoint formula. It looks confusing, it's not. So to get a midpoint, you add together the two x coordinates and half it. 2 add 4 is 6, half makes 3. You add together the two y coordinates and you half it. 4 add 10 is 14, half is 7. So to get a midpoint, you add together the two x's and you half it. You add together the two y's and you half it. That's important because that's how we're going to get our points. Okay, let's go for an example. Let's say I have 2 points. I have the point A, which is 1, 3. And I have the point B, which is 5 minus 7. I want to find the perpendicular bisector of that line. So I'm going to set it out the same way we set out the work in the last lesson. So we're going to have gradient. Right, first of all for the gradient. Now remember, you've been told the points of this line and you're going to get the gradient of this line. It is a perpendicular gradient. So the first thing I need to do is find out the gradient of the line that's been given to me. So the gradient of AB. So that's going to be minus 7 take away 3, 5 take away 1, which will be minus 10 over 4. And if I simplify that down a little bit, let's come down here, that will give me minus 5 over 2. So that's the gradient of the normal line. Now I want the gradient of the perpendicular line. So I write my wee statement. Always need that when I'm doing a perpendicular gradient. So my m perp, upside down, change the symbol. 2 over 5. So that's the gradient I'm going to use. The point, okay, I need the midpoint of this. So I'm going to add together my x coordinates and half it. I'm going to add together my y coordinates and half it. People can get a little bit mixed up with the gradient formula and the midpoint formula. You need to have it really clear in your mind. So 1 add 5 is 6, half of that makes 3. 3 add minus 7 is 3 take away 7, which is minus 4, half of that is minus 2. So I have my gradient, I have my point, and now I'm going to do my equation. So equation, y minus b equals m bracket x minus a. Let's fill in my information. There's a and b, so it's going to be y take away negative 2 equals my gradient, which remember was 2/5 x minus a. Tidy this up, that'll be y add 2. Okay, same as the last lesson, we want to get rid of this fraction, so we're going to multiply by the bottom number, which is a 5, times everything by 5. 5y add 10 will equal the 2/5, the 5's will cancel, leaving me a 2. Oh, I'm hoping I don't run out of space. Multiply it in my bracket. 5y add 10 will equal 2x minus 6. I will take 10 away from both sides. I can't fit it in, but I'll just write in it answer. 2x minus 16. And that is how we find a perpendicular bisector. So we need the gradient of the line that's been given. We then need the perpendicular gradient. To get the point, you're going to get the midpoint of the 2 points given, and then we substitute that into our equation. Let's try a different example. So let's say this time we're going to say that you've got C, which is minus 3 minus 5, and we've got D, which is 1 minus 1. And we're going to work out the perpendicular bisector of this line. First things first, let's get our gradient. So let's find the gradient of this line here, this CD. Minus 1 take away minus 5. 1 take away minus 3. Notice I'm not writing down the gradient formula. We should be good enough at this by now not to have to labour it. So that means my gradient, minus 1 take away negative 5 is minus 1 add 5, which will take me up to 4. 1 take away minus 3 is 1 add 3, which will take us up to 4. 4 over 4, my gradient is 1. I now need the perpendicular gradient. So I write my wee statement. It tells the marker we know what we're doing. And then I want to do my perpendicular gradient. So I'm going to turn it upside down and I'm going to change the symbol. Remember, 1 can be written as 1 over 1. So if I turn it upside down, it's still 1 over 1. So it's still 1, but I change my symbol to get a minus 1. Gradient sorted. Next thing is the point. So I want the midpoint of CD. Camera malfunction. So to get the midpoint of CD, you're going to add together the two x coordinates. So that's minus 3 add 1. And then we're going to half it. We're going to add together the two y coordinates. Minus 5 add minus 1. And then you're going to half it. Minus 3 add 1. That will be minus 2. Half of that is minus 1. Minus 5 add minus 1 is minus 5 take away 1, which is minus 6. Half of that, minus 3. So I have my gradient, which is minus 1. I have my point, which is minus 1 minus 3. And now I'm going to go for my equation. Okay, so A and B, we're going to go y minus b equals m bracket x minus a. So that's going to give me y take away negative 3 equals minus 1 bracket x take away minus 1. Tidy up. Y add 3 minus 1 bracket x add 1. Now I can multiply out my bracket. Minus x minus 1, and then I'm going to take 3 away from both sides. Y equals minus x take away 4. Okay, are we keeping up? Good stuff. Right, let's go for another one. This time we're going to go with the point E, which is 1, 2, and F, which is 4, 8. And again, I want the perpendicular bisector of that line. So first and foremost, we're going to go with the gradient. Okay, so for my gradient, just going to use my normal gradient formula. So that take away that take away that, which is going to give me 6 over 3. So my gradient works out to be 2. 6 divided by 3 makes 2. That's the gradient of the original line. I now want the gradient of the perpendicular line. So I write my little statement in, and then I'm going to turn it upside down and I'm going to change the symbol. So 2, remember, is actually 2 over 1. Upside down is a half. Change the symbol, minus a half. So I've got my gradient. Point. I need the midpoint of this. So remember, you're going to add together your x coordinates. 1 add 4, half. You're going to add together the y coordinates. 2 add 8, half. That's going to give me, now I've deliberately chosen this one, 1 add 4 is 5, 5 over 2. I'm going to leave as 5 over 2. I'm not going to change that to a decimal. 2 add 8, that's going to give me 10 divided by 2, that's going to give me 5. So my midpoint is this. That might present us with something a little bit more challenging, but let's see when we get there. Equation. Y minus b equals m bracket x minus a. There's my a, there's my b, my gradient was minus a half. So y take away 5 equals minus a half x take away 5 over 2. So I want to remove that fraction there, so I'm going to times by 2. If I do that, times everything by 2, 2y minus 10 equals, right, the minus a half, the 2 on the bottom will cancel with that 2, that'll leave me with minus 1. Like so. And now I need to multiply out my bracket, which will give me minus x add 5 over 2. Remember, be careful with your negative numbers. Now I'm going to add 10 to both sides. So 2y will equal minus x. Right, 5 over 2 add 10. What's that going to be? So 5 over 2 is 2.5. It's 2.5. If I add 10 onto that, I get 12.5. Alternatively, I could write it as 25 over 2 if I wanted to. I'm just going to stick with 12.5. Get rid of that. Okay, let's move on to something that requires a little bit of thought. This time we're going to go with G, which is 3,7, and we're going to go with H, which is 3,11. And I want the perpendicular bisector of that line there, if I drew it, which I'm not going to do right at this second. So first things first, like the other ones, gradient. So my gradient is going to be 11 take away 7 over 3 take away 3, which is 4 over 0. Okay class, what's 4 divided by 0? Anyone? And they want to take a bold step and embarrass themselves in front of everybody? If you cast your mind way back to one of the very first videos, you will remember this, hopefully. You cannot divide by 0. It's impossible. This is an undefined gradient. It's an undefined gradient because if I plotted what this looked like, 3, 7, 3, 11, I have a vertical line. Now you should remember that vertical and horizontal lines are perpendicular to each other, and they are a special case. So in here, the perpendicular gradient, remember, if I've got a vertical line, the perpendicular line to that would have a gradient of 0. It is a line that just goes straight across, horizontal. Point. I still need my midpoint. So I'm going to add together the x's and half it. 3 add 3, halved. I'm going to add together the y's and half it. That will give me 3 add 3, 6, halved, makes 3. 7 add 11 is 18, halved makes 9. Equation. Right. We have spoken before about the equation of a horizontal and a vertical line. We don't need to go through all the steps that we normally do. A horizontal line, like so, you should remember, or you should be able to tell me what that equation would be. Okay? It goes through the point 3, 9. You can see here it always has a height of 9. The equation is simply y equals 9. That takes a little bit of knowledge that we've used in previous lessons and puts it together with this one. Another example. This time I've got I, which is the point minus 2, 5, and I've got j, which is the point minus 2, 9. In fact, we'll change that. We'll go with I as the point 1, 7, and we'll go with j, which is going to be the point 3, 7. My mistake. Okay, we're going to work out the perpendicular bisector of this line. So we need the gradient. So same as before, y2 take away y1 over x2 take away x1. So 7 take away 7 over 3 take away 1, which will give me 0 over 2. What is 0 divided by 2? That's right, it is 0. So what does that mean? It means that we must have a horizontal line. If we've got a horizontal line, okay, 1, 7, 3, 7. So we have this horizontal line happening. Our perpendicular bisector will now be a vertical line. So in here, should have wrote this in the last one. It's an exception to the rule though. So our perpendicular gradient is going to be undefined. You need to be on the lookout for horizontal and vertical lines. So that was my gradient. My point. Again, I need my midpoint, so back up to here. Add together the x's and half it. So 1 add 3, halved. Add together the y's and half it. 7 add 7, half. That will give me 4 over 2, which is 2. 14 over 2, which is 7. Equation. We have a vertical line. It goes through the point 2, 7. The vertical line has an equation x equals the x number. This vertical line, no matter where you go on it, the x coordinate is 2, so the equation is simply x equals 2. That, people, is how you find a perpendicular bisector. You need to find the gradient of the line that's given, find the perpendicular gradient. You need to find the midpoint using the midpoint formula, and then you need to get the equation. Right, time for you to do some work. So, question 1. Find the equation of the perpendicular bisector of the line joining each pair of points. So I've got M 1, 5 and N 3, 9. Question 2. Minus 7, minus 3 and minus 1, 7. We've got question 3. 0, 5 and 1, 8. Question 4. 1, 1 and 1, 3. and question 5, minus 2, 4 and 0, 4. Hit pause, do your work. Okay, solutions. So I want gradient. So I need to do 9 take away 5, 3 take away 1, which is going to give me 4 over 2, and 4 over 2 is 2. I then want the perpendicular gradient, so I write my little statement down, and then I've got to turn 2 upside down and change the symbol. So remember, it's really 2 over 1. So my perpendicular gradient, if I turn it upside down, is going to give me a half. It was positive up there, so it's negative in here. Point. I need the midpoint of MN. So I'm going to add together the x coordinates, 1 add 3 and half it. I'm going to add together the y coordinates, 5 add 9 and half it. That will give me 4 over 2, which is 2, 14 over 2, which is 7. So I've got my gradient, minus a half. I've got my point, 2, 7, AB, just in case you wanted it. And then I'm going to go for my equation. Y minus B equals M bracket X minus A. So that's going to be Y take away 7 equals minus a half X minus 2. I want rid of this fraction, so I'm going to times by the bottom number, which is 2, times everything by 2. I get 2y minus 14 will equal, the 2's will cancel, leaving the minus 1. Multiply out the bracket. Careful on your negative numbers work. Add 14 to both sides. All done. Question 2. Again, I want my gradient. So it's going to be 7 take away minus 3, minus 1 take away minus 7. Again, really important you don't muck up your negative numbers work here, folks. So 7 take away minus 3 is going to give me 10. Minus 1 take away negative 7 is minus 1 add 7, which will give me 6. 10 over 6 is going to simplify down to 5 over 3. I want the perpendicular gradient to that. So I need my statement. Perpendicular gradient, turn my fraction upside down, change the symbol. I'm going to get negative 3 over 5. I want my point. So I need the midpoint of this. So I need to add together the x coordinates. Minus 7 add minus 1 and then half it. I need to add together the y coordinates. Minus 3 add 7 and then half it. Again, careful of the negative numbers. Minus 7 add minus 1 is minus 8. Divided by 2 is minus 4. Minus 3 add 7 is 4. Divided by 2 is 2. So I've got my gradient. It is minus 3/5. I've got my point. Now I'm going to go and get my equation. That's going to give me y minus b equals m bracket x minus a. You're going to get y take away 2 equals minus 3/5 x take away. Now, I'm going to skip a little step here. I'm going to go x take away negative 4. I'm just going to jump to x add 4. Don't tell your teachers. They'll be cross. Okay, next thing, we're going to multiply by 5. That will give me 5y take away 10 equals, the 5 cancels, leave the minus 3 on the top. X add 4 in the bracket. I'm going to multiply out the bracket. So that's going to give me minus 3x take away 12, and now I'm going to add 10 to both sides. 5y will equal minus 3x minus 12, add 10, brings me back up to minus 2. Okay, next one, number 3. Again, I want my gradient. So it's going to be 8 take away 5, 1 take away 0, which will give me 3 over 1, which is 3. I want the perpendicular gradient. I write my statement. M perp turn it upside down, change the symbol. So 3 would be 3 over 1. Upside down would be 1/3. Change the symbol, minus 1/3. I want my point. So I need the midpoint of this. So add together the x coordinates. So I'm going to go 0 add 1 divided by 2. Add together the y coordinates. 5 add 8 divided by 2. 0 add 1 is 1 divided by 2 gives me a half. Oh no, it's a fraction. 5 add 8 is 13 divided by 2 is a half. Oh, it's another fraction. This is going to be interesting. Equation. Y minus b equals m bracket x minus a. Okay, fill it in. This could get messy, people. Y minus 13 over 2 equals minus 1/3 x minus a half. The bottom number is a 3 here, but I also notice I have a 2 here. This could cause a little bit of confusion, I fear. Right, to eliminate this fraction here, I'm going to multiply by the LCM. For those who remember the first year maths, I'm going to multiply by the lowest common multiple of 2 and 3, which is actually 6. You could multiply by 3 if you want, it just means you still have a fraction over here. If I times by 6, 13 multiplied by 6 and then divided by 2 is 39. Times this by 6. This is different, so minus 1 times 6 is minus 6, divided by 3 is minus 2. Different to anything we've done so far. Remember, the bit in the bracket doesn't get multiplied. Now I'm going to multiply at the bracket. Minus 2x, careful, minus 2 times a half, sorry, minus 2 times minus a half is positive 1. And now I'm going to add the 39 to both sides. To get so. If you had multiplied this by 3, okay, you would just get something a wee bit slightly different than what I did. Okay, if you times this by 3, you would have got 3y minus 39 over 2. So you just got a little bit more of a confused fraction. Question 4. You want to get the gradient. So 3 take away 1, 1 take away 1. Which will give me 2 over 0. Yep, I included a deliberate horizontal vertical one. So 2 over 0, that would give me an undefined gradient. Okay. The perpendicular one to that, undefined is vertical, perpendicular is horizontal, which has a gradient of 0. I still need my point, so I need my midpoint of this, so I need to add together the x coordinates in half. 1 add 1, half. Add together the y coordinates in half, which is going to give me 1 add 1 is 2, 2 divided by 2 is 1, 1 add 3 is 4, divided by 2 makes 2, and then I go to my equation. I am writing out the equation of a line which is horizontal. And it goes through the point 1, 2. A horizontal line has equation y equals the y value. Y equals 2. Don't have to go through the normal steps for that one because it's a special case. Question 5. I need my gradient, which will give me 4 take away 4, 0 take away minus 2. Okay, and that's going to give me 4 take away 4 is 0, 0 take away minus 2 is 2, 0 over 2 is 0. Again, I've given you a special case. This time I have given you something which is horizontal, so the perpendicular gradient to that would be something which is vertical, which should be an undefined gradient. My point Okay, midpoint of this, so I need to add together my x's, minus 2 add 0, half, add together the y's, 4 add 4, half. That will give me minus 2 divided by 2, minus 1, 8 divided by 2, 4. I'm now going to write down the equation of this vertical line. A vertical line has equation x equals the x coordinate. X will equal minus 1. Okay, right, just a little aside. I'm going to go back up to this one just in case you multiplied out by 3 and write down what it was you would have ended up with. So we had y minus 13 over 2 equals minus a third x minus a half. Okay, let's do it as if you multiplied by 3. So if you multiplied by 3, camera, behave yourself. So if we multiply this by 3, we would get 3y minus, if I times this by 3, it's just the top that gets multiplied by 3, not the bottom. Times that by 3, minus 1. Now I'm going to multiply the bracket. Minus x plus a half, and now I'm going to add 39 over 2 to both sides. 3y will equal minus x, right, I have a half and I'm adding on another 39 halves. That would take me all the way up to 40 halves, and then 40 halves, or 40 divided by 2 is 20. Okay. Hopefully that was 5 out of 5. We'll be back soon.